Now we're going to do a little image manipulation with Python. All of those wonderful people up in graphic design who just sit there and call up images and move sliders around and think they're actually doing something with a computer are actually just fooling themselves. There is a huge amount of computer programming and math that goes into everything that they are doing. Of course, if you try and explain that to them, their eyes roll back in their head because they can't do either of those things. Anyway, what we are going to do is, or what I'm going to do is, I'm going to show you how some of that actually works. And how you could write your own image manipulation tools inside of Python, which is one of the things that I'm doing, but I don't do it for pictures and editing of regular images. I do it for astroimaging. All right, so I am trying to write an interactive tool for doing astroimaging, rectifying images one on top of another, and then if you colorize them red, green, and blue, stack them together, you get pretty pictures, like you see out on the astronomy picture of the day, which is affectionately called APOD by many of us. Again, the hashtag %% that chunks things into cells, and I want to do that this time around. Because otherwise you will be inundated with images. If you just take this program, Image Manipulation 1, and just run it, you're going to get a truckload of output, and you won't know what corresponds to what. So here it becomes really important to do this by cells. You notice that I am importing from the Python image library, the image and image filter tools. There are a huge number of tools in the PIL. I encourage you, if you are doing anything with images and image manipulation, to look into it and read the documentation. It will allow you to do a bunch of stuff. I also wrote one. I kind of wrote one function which is basically going to roll the image in the X direction. So think of an image on a continuous piece of paper, and then just shift the whole piece of paper to the left and take whatever falls off the edge on the left hand edge and bring it around to the right and paste it. So we just shift everything. If you want to move everything in the Y direction, shift it upward, and then take the top piece and put it on the bottom. You would just interchange everything that I do for the X move to a Y move, and it's pretty simple. The big thing you have to remember is that you have to reorient your head in terms of where 0, 0 is. For on your screen and for any image, your 0, 0 is the upper left hand corner. And then it moves positive to the right in X and positive down in Y. Which makes perfect sense if you think about it, because if you scroll, you can't scroll past the left-hand edge of your screen. You actually flip to a new screen, or if you've got multiple screens, you can flip back and forth and do all kinds of fun stuff. But what you can do is within a window, you can continuously scroll to the right. It has room to the right, and it has room to go downward. You can't go past the top, but you can go downward. So 0, 0 is the upper left. Everything happens from that upper left. You'll notice that I get the size of the image. With image size, I dump it into X and Y. The delta is just how much I want to move it to the left. And if the delta is 0, I error trap for that. That means that I don't want to move it at all. There's no reason to call the function if you don't want to move it at all, but I error trap for that anyway. And then what I do is you take the first part, starting at 0, 0, and then you go to the left, to the right, I'm sorry, in X, by the amount you want to chop off and move, and you go down the entire size of the image, and then you crop that, put it in a new variable. Right, you take and start at the offset, which is your delta x, right? And then you go, and at y equal to 0, you go all the way to the end of the image on the right and all the way to the bottom of the image downward, right? And you crop that. Right, then you take that second piece which you just did, which is part 2, move it over, right? Stick it at 0, 0, and plunk it in. And then take the first part that you cut off, move it over the amount, right, by the total size of the image minus delta, right, plunk that in there, right, and stitch that on to the image. You now have a totally rolled image. Right. If you roll it by small enough increments and you do lots of these, and then you take each one of those images, stitch them together, you can have a nice funky animation. But I digress. You can do all kinds of fun stuff with this. I just want to open up the image, right, which is that file. It's just a straight JPEG file. You can open up any JPEG file. The program has to be in the same folder as the JPEG. Right, if it's not, you're going to have to type in the entire path to the file, which can get to be a little tedious and really annoying. So I just stick the image in with where the program is, and then I'm going to show the photo. I'm going to save that photo in a second variable, which is photo 2. I am going to then print out in this lower right hand corner here, right, the output section, the format of the photo, the size of the photo, the mode of the photo, and then I am going to apply a filter. I'm going to apply a blur to the image and then show you what that looks like. I notice that I'm going to output a bunch of photos, so with a bunch of things happening, and what I want to do is like chunkify this so that we don't lose what goes with what. So if I start up here and just run that first, cell, it takes a bit. I notice that I am eating memory. I went from 58 to 64. And this is not a large image. I will just let you know. So here we are. First we'll do the print photo format. It is JPEG. This is the size of the photo. So it's 2197 by 1463. That's pixels. If you're trying to see whether or not it will fit on your screen as the background image, and of course the mode of the photo is RGB. Red, green, blue. You can get CMY, cyan, magenta, and yellow. You can get a couple other things if the photo is PNG. It will do some different things to you. If you're not, into graphics and photo, don't worry about it. You can also get RAW, which would be RAW. If you're shooting camera RAW images, that will come out, and you can manipulate those. I shoot camera RAW a lot of times if I'm doing astro imaging, astrophotography. Right. Now, working backwards, we got a blur and then we got a photo. So if I bring that back, notice that it gives you a temporary file. You can save that file if you'd like. That's the actual image. That is the blur. It numbers them consecutively. It gives them funky names. I have no idea why. And Python always outputs in PNG format. By default, you have to do some very heavy lifting to get it to output in anything else than a PNG format. Notice that it gives you a very soft blur. You could blur and then blur it again and then blur it again to get different amounts of blur. You can also use, there's another function in there which will allow you to specify the amount of blur if you're trying to soften the edges of things and do all kinds of fun manipulation. Now, Variable Explorer. Notice that we pulled in F1. F1 is type image, right, and it is giving you all that information, right? Because that's F1, right? That's we blurred the thing. Right, photo and photo 2 are exactly the same, right? They're supposed to be exactly the same, right? Now, if I come down here and I run the next section, we're going to get some fun stuff. Notice the first thing that should come out is an edge enhance, then a contour, and then a smoothing of the photo. All right, we should get at least 3. All right, that's the 4th one. Notice the 4th one is a tilt. Right, you can take any image and rotate it. Right, this one is rotated by 30 degrees. This one is the sharpen. Just move everything over a little bit here. All right. You notice that this one, the photo rotate 30 show. Right. That is just taking the photo and the file photo, rotating it 30 degrees, and then dumping it onto the screen. That was that 30-degree rotate. All right, the next one, as if we step backwards through things, is going to be the smooth. It's going to try and basically smooth out all of the imperfections in the photo. All right, so it's in essence a deblurring and trying to sharpen. This should sound like things that are built into your, if you have iPhoto, whether it's on your phone or whether it is on your computer, or I'm pretty sure Microsoft has something similar where you can like touch up your photos and do all kinds of fun stuff. This is the contour. It is actually taking the different values and showing you the edges and the overall structure of the photo. This is very, very useful in a lot of science. But the artsy people love this stuff too. It's also, you can take, remember, this is any JPEG, you could take this thing and you could run a contour on this, and it's basically a contour plot of any mathematical function and or map. And this thing is edge enhanced. Notice it looks a little speckled, and what it's trying to do is it's looking for edges. It is looking for hard, sharp, delineated edges separating one thing from another, and it is trying to enhance those edges at the cost of making everything else a little more speckled and a little less clear. So it is looking to pick out all the hard edges, like the hard edges between the buildings, and the the bumper and the tire. His scarf to his jacket, anything that we've got. And now, notice that photo and photo 2 haven't changed. We've just added an F2, F3, F4. So we've changed stuff, but everything is the same. Everything, all the size is the same, the image type is the same. We're all good. Now I get to the last piece. I'm going to run this last piece. We're going to see a difference now. That's a thumbnail. This is a roll. Let me move this down a little bit. That's a crop. That's what the crop is doing. Now let me move this down a little bit. Things have now drastically changed. Look at photo and photo 2. When I ran thumbnail on photo, even though photo 2 is supposed to be, right, the way most programmers think of it, if I said photo equals photo 2, I have created two new variables, right, which are totally independent. Not in Python. Photo and photo 2 are pointing to the exact same thing. So when I change photo, I change photo 2. When I change photo 2, I change photo. Everything is exactly linked together. Right, so when I thumbnailed that thing, it changed both of them. Notice that F1, F2, F3, F4 have been left alone. Right, so I could go back and reference F4, for instance, and that's perfectly fine. Notice that not only that, but I have cropped this thing. Right, that is the crop function. Right, photo crop box. Right, that photo crop does not change the original photo. Right, that dumps it into box. Right, I have a new variable up there which is box. Notice that it's type tuple, not image. Right, so the box is what the size of the crop is going to be from, in this case, the upper left hand corner over 981 pixels and down 480 pixels. And then region gives me the new crop. And region is right there. And region has resized. And so I'm showing region. And that region is absolutely that photo. So if I call up the variable region and I try and do anything to it, I'm doing only stuff to this little itty bitty piece of it. Now, the role is this thing. Notice that I have taken and I have cut the doctor off here. For those of you who don't know, this is the Doctor Who. It's actually the fourth Doctor. That's Tom Baker, Liz Sladen, and that's the gentleman who plays Harry, with Bessie the car. But in any event, we have chopped off this entire section over here on the right, and I have moved it over, and then slid this other part of the photo to the left, and so we are there. And it's moved everything. Notice that as soon as I did this, though, I have rolled this in the X direction, and then I have shown it. I altered the photo. Photo is no longer the original photo, the original file. It is now this rolled thing. It is the new size, and the new object. You can tell that because then when I declare the next thing and I just say, oh, do a thumbnail of it, notice it's doing a thumbnail of the rolled object. It is not the original photo anymore. So this roll function that I wrote alters the original file in memory, not on the disk. Nothing is permanent on the disk until I go ahead and I were to go ahead and say save one of these things. And I can go ahead and export this, and I can save it, and I can do all kinds of other stuff to it. But that does not change that file 3.jpg, which is on the disk. This was all, remember, these are all PNGs when I do this. There's not a whole lot of output, except for that and the image files. But the big thing is being able to look at the type, look at the variables, and notice that the size changes. And now if I wanted to do anything and I wanted to do it to the original file, I got to go back up here, and I think F4 is probably the closest thing that I've got to the original photo. It just smoothed it out a little bit. It didn't do anything. So I'd have to recall F4 and then continue on. So that's the image manipulation with using the Python image library. All right, then the next thing we're going to do is do more image manipulation, but do a little bit more math on it, all right, to see how that works.